Alright, let's do some Idris and write a type-safe printf function. So let's learn what printf does by using some Haskell. So printf test will print out test. If we put in a placeholder, so %d and pass in a integer, then it gets then the format string, so the string that we pass in, gets formatted by the arguments that we pass. So %s means that we're going to take a string, so we can pass in the string test, and then that gets interpolated into that string. So what happens if we pass in a value of the wrong type? It throws an exception. What if we pass in too many arguments? It throws an exception. What if we don't pass in enough arguments? It throws an exception. So the idea is that Haskell throws an exception because it doesn't know enough about the input type, the input value, the input format string. Theoretically, Haskell could have like a validation type. It could return maybe, or it could return either, or it could return some sort of validation type, and then you'd have to handle that yourself. Idris is a dependently type language though, so we can have a value that determines the type, and we don't have to do any error handling because we know it's correct uh, uh, by inspecting the value at compile time. So let's write some Idris and write a type-safe printf function. We'll add a pragma called default, and this means that will be totaled by default, which means Idris will have a totality checker, ensuring that we pattern match over everything in a ADT, and also that our programs or our functions terminate, or at least are productive, meaning that they do something and they don't get in an infinite loop. So we'll make this format. We'll treat this as an AST for our format string. So we'll say that if you get a %d, then that will be an fint case, and we'll have a recursive data type saying that we've got a %d, and now we need to have the rest of the format string. So f string, so that's will be %s. I'll leave little comments up here. So %d and %s. We'll have f other, meaning that we've got some other character, so none of the above. So there'll be like a through to z or something like that. Or eventually we get to the end, and that'll just be nothing. So we get a %d, we get a %s, some other characters, and then we'll end. So let's go from a list of characters into this format data type. We'll parse this list of characters. So if we have a %d, so we'll just recurse, we'll return back an fint, so we've parsed %d into an fint, and we'll recurse. If we get a %s and the rest of characters, then we'll do something very similar. If we get some other character, so this will be the a to z, the f other thing that we've described above, then we remember what the character is, and we'll recurse. Eventually we'll get to the end of the string, and that'll just be the end ADT. So now we've got this format. Let's convert a format into a type. So Idris is interesting in that we can have values create types, or values determine types. So given a format AST that we have above, let's determine what type it should be. So printf, given some sort of a %d, then it should actually be a function from int to the rest. So if we've got a %d, then we say it's an int to depending on the rest of the format string. So f string will be a string. So if we give a %s, then it's a string. If we give %d, it's an int. And we need to get the rest of it. So if we find some other character, well, it doesn't actually create a function type, it's just depending on the rest of the characters in that format string. Since we don't actually use the C here, we don't actually care about what character it is, we'll just leave an underscore in to say that we don't care. Eventually we'll get to the end, and the result type should be a string. So it'll be so if we give it like percentage, if we give it if we give percentage %d as our format string, and then ABC, the type should be int2 string. So let's make a format string function, which will take a string and then create a format for us. So strings are not just lists of characters in Idris, unlike Haskell. They're an independent type, but we can unpack a string into a list of characters, and then we can convert it into a format. So let's give this a try in the REPL. So we'll load this up, and now we can say format string of %d, %s. We'll put hello in the middle. Well, that creates some sort of AST for us. But now what if we were to ask to interpret that? There we go, that's a little bit clearer. So what if we were to interpret that into a type? So our format string into a type. So the %d says that it's an int to something. It's an int to something. The percentage s means that it's a string to something. And in the end, we result in a string. So, looks like that's working. We can create a type based on this format string. Now what we want to do is create a function as well. We want to actually make a value of this type. It's cool that we can get the type out, but what if to make the printf actually work, we need to create a function of this type. So given some sort of format, so here we're saying a value of format called format, fmt, we should be able to get back a, we should be able to get back a string, so because we're going to make this a recursive function, we need to have an accumulator. So string to a value of the type of interpreting that format into a type. So value of interpreting that format. So given given the fint case, then we know that's going to be a function from, we know it's going to be int to something. So let's make a lambda. So this is lambda syntax in Idris. So \i. So we're accepting an I, which will be an int. It needs to be, so the question marks there were actually because it's recursive. So it's going to be recursive. And then a, we need to add on the int that we get. So we'll just show it, add it onto the accumulator. So this is going to be very similar for string, except we don't need to show it because we already have a string. We don't need to convert it into a string. Given some other character, well, this doesn't need to be a string. This needs to be just a recursive call. But we do need to update the accumulator by adding the character on. Singleton is a function in Idris which will take a character and turn it into a string. And when we get to the end, then we can just return the accumulator. Awesome. So printf we can write now, and that will take a string. So this will take the format string, and it will give back a value of the of interpreting that format into a type. So it will give back a value dependent on the format string. So format string will parse a string into the format for us. We can pass it into interp format. And now printf takes that string and just converts it into a function for us. And the accumulator that we need to pass in is just the empty string. We don't have anything, it'll build up by appending to that string, so we can just pass in the empty string as the initial state. So we've used the string to create a type. We've passed the string into a format ASD, and then we've interpreted that format ASD into a type. And then we've use that same string at the value level to create a function that inhabits that type. So this should be type safe. Let me load this up. So now we have a type safe printf by if we give it a value. Let's just start off with the easy one. So given test, so it doesn't see any percentage signs, doesn't see any placeholders, so it knows that the type will be string. So we can follow that through by just seeing here, if it doesn't see any percentage signs, eventually it passes as just something that gets to just be an f others. It'll just be a recursive f other data structure with an end at the end, and then when we interpret that, it'll just keep recursively interpreting that into a final value of a string. And the to function does something very similar. If we put in a %d, now we've inserted an fint into our AST, so we know it's going to be an int to something. Now that something will obviously just be an fnd in the end, so it'll just be an int to string. So we can see here that Idris is able to print what the string actually represents, but the interesting thing is that the type is int to string. So let's give it an int, and there we can see it can work. Now if we give it %s, we can see that it won't compile. Or if we give it %d and try and give it a string, it'll say can't convert a string into an int, so they don't work. We can't pass in too many arguments because it's not a function. It's saying here that it's not a function. It does not have a function type. And if we don't give it enough arguments, Idris won't throw an exception or anything, because it will just verify that you never use it in a real program without enough arguments. So I think this is really interesting. We've been able to write a type-safe printf without the use of macros. We've been able to just use what some people in independently typed, some users of dependently typed languages call metaprogramming, but based on values. Some people say that dependently typed languages don't really need macros because we're able to use metaprogramming just by depending on values, which I think is pretty interesting. But yeah, I think this is a real motivation for what dependent types are kind of about. We can make things type safe by depending on values. Printf is a really good example here because the type depends on the format string. And I think this might have provided a little bit of motivation to learn Idris. Idris is a very practical form of dependently typed languages. It can compile down to JavaScript, or it can compile down to Java or C. So you could actually use this for real things. It may not be the most stable thing to rely on at the moment, but it's not really nice to play with. It offers a really powerful type system, something much more powerful than Haskell. And I think it's something that you should definitely look into.